हेलो फ्रेंड्स, तो राना अकेडमी में आपका स्वागत है। हमने स्टार्ट किया 12th क्लास के एनसीईआरटी की केमिस्ट्री की वन शॉट सीरीज, जिसमें हमने 12th यूनिट तक कंप्लीट किया है। स्टार्ट कर दे 13 यूनिट्स, जो कि है हमारा अमाइंस। Amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecule by alkyl aryl groups. In nature, they occur among proteins, vitamins, alkaloids, and hormones. Synthetic examples include polymers, dyestuff, and drugs. Two biologically active compounds, namely adrenaline and ephedrine, now both the blood pressure. Novocaine, a synthetic amino compound issued as an anesthetic in dentistry. Benadryl, a well-known antihistaminic drug, also contains tertiary amino group. Quaternary ammonium salts are used as superfractions. Surfactants or diazonium salts are intermediates in the preparation dyes. In this unit, we will learn about amines and diazonium salts. Amines can be considered as derivatives of ammonia, obtained by replacement of one or two or all of the three hydrogen atoms by alkyl or aryl groups. Like ammonia, nitrogen atom of amines is trivalent and carries an unshared pair of electrons. Nitrogen orbitals in amines are therefore are sp3 hybridized, and the geometry of amines is pyramidal. Each of the three sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen or carbon, depending upon the composition of amines. The fourth orbital of nitrogen in all amines contains an unshared pair of electrons. Due to the presence of unshared pair of electrons, the angle C and E, where E is C and or H is less than 109.5 degree. For instance, it is 108 degree in case of trimethylamine, as shown in figure 13.1. Classification. Amines are classified as primary, secondary, and tertiary amines, depending upon the number of hydrogen atoms replaced by alkyl or aryl groups in ammonia molecule. If one hydrogen atom of ammonia is replaced by R and AR, we get RNH2 and ARNH2, a primary amine. If two hydrogen atoms of ammonia of one hydrogen atom of RNH2 are replaced by another alkyl aryl groups, now what would you get? RNHR. Secondary amine. The second alkyl aryl group may be same or different. Replacement of another hydrogen atom by aryl alkyl groups leads to the formation of tertiary amines. Amines are said to be simple when all the alkyl or aryl groups are the same. The mixed when they are different nomenclature. The in common system, an aliphatic amine is named by prefixing alkyl group to amine, that is primary alkyl amine as one word, methylamine. In secondary and tertiary amines, uh, when two or more groups are the same, the prefix "-" is appended before the name of alkyl group. And is in IUPAC system, primary amines are named as alkyl amines, and the name is derived by replacement of E of alkene by the word amine for amino group is present at different positions in the parent chain. Their positions are specified by giving numbers of the carbon atoms bearing NS2 group, and suitable prefix such as da, tri, etc. is attached to the amine. The letter E of the suffix of or the hydrocarbon have a part is retained. For example, H2N, CH2, 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 NH2 is named as ethane 1,2-diamine. Now, to name secondary and tertiary amines, we use locant N to designate and the subsequent substituent attached to a nitrogen atom. For example, CH3 and through NH, CH2 CH3 is named as methylethene amine, and CH3 CH2 is 3 times N is named as N diethylene thiamine. Now more examples are given in table 13.1. In aryl amines, NH2 group is directly attached to the benzene ring C6H5NH2, and this is the simplest example of aryl amine. Now, in common system, it is known as aniline. It is also an accepted IUPAC name. Now, while naming alkyl aryl amines, according to IUPAC system, suffix "e" of arine is replaced by amine. Thus in IUPAC system, C6H5O-2 is named as benzenamine. The common and IUPAC names of some alkylamines and arylamines are given in table 13.1. Preparation of amines. Reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium, and platinum, and also by reduction of with metals in acidic for medium nitroalkanes can also be similarly reduced to the corresponding alkylamines. Reduction with iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Thus, only the small amount of hydrochloric acid is required to initiate the reaction. Second, ammonolysis for of alkyl halides. You have read unit 10 class 11 12 that the carbon halogen bond in alkyl and benzyl halides can be easily cleaved by the nucleophile. Hence an alkyl and benzyl halide on reaction with an ethanolic solution of ammonia undergoes a nucleophilic substitution reaction in which the halogen atom is replaced by an ammonia group. Now this process is of cleavage of the CX bond by ammonia molecule is known as ammonolysis. The reaction is carried out in the sealed nucleophile and can further react with alkyl halide to form secondary and tertiary amines and finally quaternary amine ammonium salt. The free amine can be obtained from the ammonium salt by treatment with a strong base. Ammonolysis this has the disadvantage of yielding a mixture of primary, secondary, and tertiary amines and also a quaternary ammonium salt. However, primary amine is obtained as a major product by taking large excess of ammonia. The order reactivity of halides with amines is Ri is greater than Rbr is greater than Rcl. Reduction of nitriles. Nitriles are on reduction with lithium aluminum hydride or catalytic hydrogenation produced and primary amines. This reaction is used for ascent of amine series. That is for preparation of amines containing one carbon atom more than the starting amine. Reduction of amides. The amides of non-reduction with lithium aluminum hydride yield amines. Gabriel thalamide synthesis. Gabriel synthesis is used for the preparation of primary amines. Thalamide treatment with ethanolic potassium hydroxide from potassium salt of thalamide, which on heating with alkyl halide followed by alkaline hydrolysis produces corresponding primary amine or aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by thalamidium. Hoffman bromide degradation reaction. Hoffman development a method of preparation of primary amines by treating an amide with bromine in an aqueous and ethanolic solution of sodium hydroxide. In this degradation reaction, migration of an alkyl or aryl group takes place from the carbonyl group carbon of the amide to the nitrogen atom. The amine also formed contains one carbon less than that present in the amide. Physical properties. The lower aliphatic amines are gases with flashy odor. Now, primary amines with three or more carbon atoms are liquid and still higher ones are Solid aniline and other aryl amines are usually colorless but get colored on storage due to atmospheric oxidation. Lower aliphatic amines are soluble in water because they can form hydrogen bonds with water molecules. However, solubility decreases with increase in the molar mass of amines due to increase in the size of the hydrophilic alkyl part. Higher amines are essentially insoluble in water. Considering the electronegativity of nitrogen of amines and of oxygen of alcohol as 3.0 and 3.5 respectively, you can predict the pattern of solubility of amines and alcohols in water out of butanol and butanol amine, which will be more soluble in water, and why amines. Remember that alcohol are more polar than amines and form stronger intermolecular hydrogen bonds than amines. Primary and secondary amines are arranged in intermolecular association due to hydrogen bonding between nitrogen of one or more one and hydrogen of another molecule. Now, this intermolecular association is more in primary amines than in secondary amines, as there are two hydrogen atoms available for hydrogen bond formation in it. Tertiary amines do not have intermolecular association due to the absence of hydrogen atom available for hydrogen bond formation. Therefore, the order of boiling points of isomeric amines is as follows: primary is greater than secondary is greater than tertiary. Intermolecular hydrogen bonding in primary amines is shown in figure 13.2. The boiling points of amines, alcohols, and alkanes are of almost the same molar mass are shown in table 13.2. Chemical reactions: difference in the electronegativity between nitrogen and hydrogen atoms and the presence of unshared pair of electrons over the nitrogen atom makes amines reactive. The number of hydrogen atom attached to a nitrogen atom also decided the course of a reaction of amines. That is why primary, secondary, and tertiary amines differ in many reactions. Moreover, amines behave as nucleophiles due to the presence of unshared electron pairs. Some of the reactions now of amines are described below. Basic character of amines: amines belong being basic in nature, react with acids to form salts. Chemical reactions: difference in electronegativity between nitrogen and hydrogen atom and the presence of unshared pair of electrons over the nitrogen atom makes amines reactive. The number of hydrogen atoms attached to nitrogen atom also decides the course of reaction of amines. That is why primary, secondary, and tertiary amines differ in many reactions. Moreover, amines have behave as nucleophiles due to the presence of unshared electron pair. Some of the reactions of amines and are described below. Basic character of amines: amines being basic in nature, react with acids to form salts. Amine salts are on treatment with the base alkyl base like NaOH regenerate the parent amine. Amine salts are soluble in water but insoluble in organic solvents like ether. This reaction is the basis of the separation of amines from the non-basic organic compounds insoluble in water. 9. The reaction of amines with mineral acids to form ammonium salts shows that these are basic in nature. Amines have an unshared pair of electrons on nitrogen atom due to which they behave as Lewis base. Basic characteristics of amines can be later better understood in terms of their Kb and pKb values of explained below. Larger the value of Kb or smaller the value of pKb, stronger is the base, and the pKb values of few amines are given in table 13.3. The pKb values of ammonia is 4.75. Aliphatic amines are stronger bases than ammonia due to 1+1 effect of alkyl groups leading to high electron density on the nitrogen atom. Their pKb values lie in the the range of 3 to 4.22. On the other hand, aromatic amines are weaker bases than ammonia due to the electron withdrawing nature of aryl group. pKb values of amines and in aqueous phase. You may find some discrepancies while trying to interpret the pKb values of amines on the basis of 1 plus 1 and plus minus 1 effect of the substituents present in amines. Besides an inductive effect, there are other effects like solvation effect, steric hindrance, etc., which affect the basic strength of amines. Just ponder over. You may get the answer of in the following paragraphs. Structure basicity relationship of amines. Basicity of amines is related to their structure. Basic character of an amine depends upon the ease of formation of the cation by accepted a proton from the acid. The more stable the cation is relative to the more basic in the amine. Alkylamines versus ammonia. Let us consider the reaction of the alkylamine and ammonia with proton to compare their basicity. Due to the electron releasing nature of alkyl group, it pushes electrons towards nitrogen and thus makes the unshared electron pair more available for sharing with the proton of the acid. Moreover, the substituted ammonium ions formed from the amine gets stabilized due to dispersal of the positive charges by the plus 1 effect of the alkyl group. Hence, the alkylamines are stronger bases than ammonia. Thus, the basic nature of aliphatic amines should increase with increase in the number of alkyl groups. This trend is followed in the gaseous phase. The order of basicity of amines in the gaseous phase follows the expected order. Tertiary amine is greater than secondary amine is greater than primary amine. NH3 is greater than. The trend is not regular in the aqueous state as evident by their pKb values given in table 13.3. In the aqueous phase, the substituted ammonium cations gets stabilized by the solvation with water molecules. The greater the size of the ion, lesser will be the solvation and the less stabilized in the ion. The order of stability of ions are as follows: decreasing order of extent of H bonding in water and order of stability of ions by solvation. Greater is the stability of the substituted ammonium cation, stronger should be the corresponding amine as a base. Thus, the order of the basicity of aliphatic amines should be primary, secondary, and tertiary, which is opposite on the inductive effect based on order. Secondly, when the alkyl group is small, like CH3 group, there is no steric hindrance to H bonding. In case of the alkyl group is bigger than the CH3 group, there will be a steric hindrance to H bonding. Therefore, the change of nature of the alkyl group, that is from CH to CH3 and C2H5, results in change of the order of the basic strength. Thus, there is a interplay of the inductive effect, solvation of effect, and steric hindrance of the alkali group, which the order of basic strength in case of methyl substituted amines and ethyl substituted amines in aqueous solution is as follows: aryl amines versus ammonia. pKb values of aniline is quite high. Why it is it too so? It is because in aniline or was other aryl amines, The NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on nitrogen atom to be in conjugation with the benzene ring, and thus making it less available for protonation. If you write different resonating structures of aniline, you will find that aniline is a resonance hybrid of the following five structures. On the other hand, aniline and ion obtained by accepting a proton can have only two resonating structures. Calculate. We know that greater the number of resonating structures, greater is the stability. Thus, you can infer that aniline 5 resonating structures more stable than ammonia and lithium, and hence the proton acceptability or the basic nature of aniline or other aromatic amines would be less than that of ammonia. In case of substituted aniline, it is observed that electron releasing groups like OCH3 CH3 increases basic strength, and, whereas the electron withdrawing groups like NO2, SO3H, CWH, X decreases it. Alkylation. Amines undergo alkylation on reaction with alkyl halides. Refer Unit 10, Class 12. Acylation. Aliphatic and aromatic primary and secondary amines react with the acid chlorides, anhydrides and esters by nucleophilic substitution reaction. This reaction is known as acylation. You can consider this reaction as the replacement of hydrogen atom of NH2 and NH is greater than a group of by the acyl group. The products obtained by acylation reaction are known as amides. The reaction is carried out in the presence of the base stronger than the amine, like pyridine, which removes HCl so formed and shifts the equilibrium to the right hand side. Amines also react with benzoyl chloride CH6H5COCl. This reaction is known as benzylation. Now, do you think the product of the reaction of amines with carboxylic acid? They form salts with the amines at room temperature. Carbylamine reaction with nitrous acid, reaction with aryl sulfonyl chloride, Heisenberg's reagent. Electrophilic substitution reaction, nitrogen direct nitrogen reaction, nitration. Then उसके बाद diazonium salts, methods of preparation of diazonium salts, physical properties, chemical reactions. Importance of diazonium salt in synthetic of aromatic compounds. Summary. Amines की summary. Amines can be considered as derivatives of ammonia obtained by replacement of hydrogen atoms with alkyl and aryl groups. Its replacement of one hydrogen atom of the secondary amines are characterized by the structure of R2NH and RNH prime, and tertiary groups are different, like ammonia. All the three types of ammonia amines have one unshared electron pairs on nitrogen atom, due to which they behave Lewis spaces. Amines are usually formed from nitro compounds, halides, amides, imides, etc. They exhibit hydrogen bonding, which influence their physical properties. In alkyl amines, combination of electron releasing steric and high edge bonding factors influence the stability of the substituted ammonium cations in protic polar solvents, and thus affect the basic nature of amines. Alkyl amines are found to the stronger bases than ammonia, and in aromatic amines, electron releasing and withdrawing groups respectively increase and decrease their basic character. Aniline is a weaker base than ammonia. Reactions of amines are governed by availability of the unshared pair of electrons on nitrogen and influence of the number of hydrogen atoms at the nitrogen atom on the type of reactions and nature of products is responsible for identification and distinction between the primary, secondary and tertiary amines. P to low NAS sulfonyl 1 chloride amino group in aromatic ring offenses reactivity of the aromatic amines. Reactivity of aromatic amines can be controlled by acylation processes, that is by treating with acid chloride or acetic anhydride. Tertiary amines like trimethylamine are used as insect attraction. Aryl diazonium salts, usually obtained from aryl amines, undergo replacement of the diazonium groups with the variety of nucleophiles to provide advantageous methods for producing aryl halides, cyanides, phenols, and aryls by reductive removal of the diazo ground. Coupling a reaction of aryl diazonium salts with phenols or aryl amines give rise to the formation of azodines. सो अमाइंस की रहती समरी. अमाइंस 12th का हमारा चैप्टर है एनसीईआरटी का, जिसको हमने वन शॉट सीरीज में कवर अप किया है. अमाइंस में हमने अभी तक देखा अमाइंस, स्ट्रक्चर ऑफ अमाइंस, क्लासिफिकेशन, नॉमेनक्लेचर, प्रिपरेशन ऑफ अमाइंस, फिजिकल प्रॉपर्टीज, केमिकल रिएक्शंस, methods of preparation of diazonium salts, physical properties, chemical reactions, importance of diazonium salts in synthetic of aromatic compounds, then summary. सो ये हमारा था 12th क्लास का एनसीईआरटी का चैप्टर अमाइंस. प्लीज़ इस वीडियो को ज़्यादा से ज़्यादा लाइक कीजिएगा एंड प्लीज़ लाइक शेयर एंड सब्सक्राइब. थैंक यू सो मच फॉर वॉचिंग.